So when we're looking at the prime factorization, what we want to do is just start with something familiar that we can divide. So we have an 8, and I need two numbers that multiply together to get an 8. Well, I do know that those two numbers can be 4 and 2. And it doesn't matter the order that you do it in, but what I want to keep doing is breaking down these numbers until they are prime, which means their only factors are 1 and themselves. So 2 is prime. He's going to come along for the ride. So there's a 2. And then 4 is not prime. I can break him down some more. So he becomes 2 times 2. So the prime factorization of 8 is going to be 2 times 2 times 2, which is going to be 2 to the third power. Okay, so let's try 12. What two numbers can I multiply together to get 12? Well, we got some options. We could do 2 and 6. We could do 4 and 3. And we could do 12 and 1, which really doesn't help us much at all. So we're just, let's start with 4 and 3. Simply because I like how it lines up with what we did the last time. 3 is prime, so he's going to come along for the ride. And then 4 breaks down to 2 times 2. So what do I have? I have 2 as a factor twice times 3. Okay, what happens if I had started with 6 and 2? Okay, well 6 is the same thing as 3 times 2, and that time 2 comes along for the ride. So I end up with 2 squared times 3. So I get the same answer. It doesn't matter how you start, it just matters that you get to the same answer. So let's try 84. 84 is going to be the same thing as 12 times 7. Okay, so I can break 12 down, and he can be 4 times 3. 7 can come along for the ride because he's prime. And then 4 will break down as 2 times 2. 3's along for the ride, and 7's along for the ride. So what we notice now is that this bottom row is our prime factorization. So I have 2 squared times 3 times 7 is the prime factorization of 84. So let's try 90. Well, 90 is going to break down just in an easy way. It could be 30 times 3. I'm going to do 9 times 10. Remember, you'll get the same answer. So what does 9 break down to? 9 breaks down to 3 times 3. 10 breaks down to 2 times 5. So my prime factorization is 3 squared times 2 times 5. So let's move on. Find the least common multiple of each pair of numbers using the prime factors method. So what we're going to do is we're going to break down each number. So 8 is going to break down to 4 times 2, which is 2 times 2 times 2. Okay? 12 is going to break down to 4 and 3, which gives me 2 times 2 times 3. So here's what I want to notice. I need to have the most of each representative factor. So this one has 3 2's. This one only has 2 2's. Okay, so 3 is bigger than 2, meaning the quantity. I've got 3 of these 2's here. I've got 2 of these 2's here. So I'm going to grab the most that's represented. So 8 has the most, so I'm going to grab 2 times 2 times 2. Okay, so let's go to the next factor. These are all still 2's. These are all still 2's. There's a 3. So he's got 1 3. He's got no 3's. So this one is going to be the most at a single instance of 3. So when I multiply this together, I get 2 times 3, or sorry, 2 to the third times 3, which gives me 8 times 3, which gives me 24. So if you think about it this way, what is the smallest number that 8 will divide into evenly and that 12 will divide into evenly? So what I usually do is I take multiples of the larger numbers. So 12 times 1. Does 8 go into 12 times 1? No. Does 8 go into 12 times 2? Well, 12 times 2 is 24. So 8 does go into 12 times 2. And so 24 is going to be your least common multiple. So let's try 84 and 90. So when I break down 84, which we just did up here, 84 is going to break down to 12 times 7, which is going to be 4 times 3 times 7, which is 2 times 2 times 3 times 7. 90 breaks down to 9 times 10, which gives me 3 times 3 times 2 times 5. So what factors do I need? I'm going to need some 2s, some 3s, some 7s, and some 5s. That's what so I need a representative of every factor. I just want the most. So looking at the 2s, he's got a quantity of 2, 1, 2. He's got a quantity of 1, so I need 2 2s. So I need a 2 and a 2. So let's move over to the next factor. Here's a 3. He has 1 of them. He has 2 of them, so I need to take the most. So I'm going to take a 3 times a 3. Okay, so I've addressed the 2s. I've addressed the 3s. Well, I'm going to need a 7. So here's a 7. So he has 1 7. He doesn't have any 7s. And then I'm going to move over. I've already manhandled the 3s. I've already dealt with the 2s. So now let's deal with the 5. Well, he's got 1 5. He's got no 5s. So whatever this answer is my prime factorization. So grabbing my calculator, I am going to do 2 times 2 times 3 times 3 times 7 times 5. Which gives me 1260. So this one's least common multiple. In other words, the smallest number that both of these will divide into evenly is going to be 1,260. Okay? Now we're going to work on some order of operations. So looking at the order of operations, reading this from left to right, what do I have? I've got some division. I've got some parentheses that have multiplication on the inside. I've got addition, and I've got division. So reading from your textbook, in your guided reading, you learned that order of operations is PEMDAS. So please excuse my dear Aunt Sally. So the P is for parentheses, or you could broaden it, and you could say grouping symbols. Okay, grouping symbols. There you go. Okay. E is for exponents. So this is the order that I work through these things on. M is for multiplication. D is for divide. A is for add. And S is for subtract. So here's what we know. When multiplication and division occur at the same time, we do it from left to right. Okay, so just because M appears first doesn't necessarily mean that I will do it first. If there's multiplication and division, I work it from left to right. Same thing with addition, subtraction. Why won't my hand do that? Okay, from addition, subtraction, if it appears, you work it from left to right. Work it from left to right. So looking at this, I need to do what the parentheses say first. So that means do what's inside if there's anything to do. So that I'm going to recopy everything else. So that gives me a 9. Oops, sorry, that does not. That gives me a 20. Good heavens to Betsy. Okay. Now looking at this, I've got division, addition, division. So I need to do the division first. So 40 divided by 20 is going to be 2. Plus 24 divided by 6 is going to be 4. And now I've got 2 plus 4 is 6. So using order of operations, I get an answer of 6. So let's come down here, read it from left to right. I've got subtraction, I've got multiplication, and I've got addition. So I need to do this in order of operations. That means I need to do the multiplication first. So I'm going to have 3 minus 12 times 4 is 48. And then I'm going to add 18. Okay, so 3 minus 48 is going to give me a negative 45. So remember, work it from left to right. And then negative 45 plus 18 is going to be a negative 27. So that is using order of operations. So let's look at this next one. Doing I've got some addition inside of parentheses attached with an exponent, and then some division. So do what's inside the parentheses first if you can. So that gives me 4 plus 5 is 9. So I have 9 squared divided by 3. Okay? So now I've got exponents versus division. So I need to do exponents first. So I've got 81 divided by 3. Because 9 times 9 is 81. And then 81 divided by 3 is going to be 27. Okay? So this last one is kind of fun because we've got exponents on exponents. We've got parentheses. We've got division. We've got multiplication. And we threw a negative at you. So what am I going to do first? If you have stuff like this, always work from the inside out. So notice that on the very inside, you've got some parentheses. You've got brackets on the outside. But on the inside, you've got parentheses. So I'm going to work at those first. So I get 16 divided by 8 minus 4 is 4 squared. And then I'm going to square that whole thing. So all I did was 8 minus 4. Everything else is the same. So now keep looking on the inside. Now I've got 16 divided by 4 squared. So between division and exponents, what do I do first? I'm going to do the exponents first. So everything else is coming along for the ride. So I get 16 divided by 4 squared is 16. Okay, so now work on the inside first. So all that's left to deal with is your division. So 16 divided by 16 is 1. And then 1 squared. That exponent only belongs to the 1. So this is multiplication, and this is exponents. So I need to do exponents first. So it gives me negative 2 times 1, because 1 times 1 is just 1. And that gives me a final answer of negative 2. So for our last one, what we're going to do is combine like terms. So I'm going to put a box around everything that matches. So I have x squareds here, and I got x squareds there. So I have 3x squareds here, and a negative 4x squareds there. I have constants. I have got a positive 11 and a negative 12. And then for x's, I've got a negative 12x and a positive 3x. So I'm just going to rewrite and put everything in order. Okay? So I've got 3x squareds minus 4x squareds. Then I've got a negative 12x plus a 3x. Then I've got positive 11 and negative 12. So I just put my purple boxes together, I put my green circles together, and I put my blue underlines together. And now just count and tell me how many you have. I have 3x squareds here minus 4x squareds there, means I've got a negative 1x squared. So 3 minus 4 is negative 1 of them. Negative 12x's plus 3x's is going to be a negative 9x's. So only the coefficient changes. Don't change this to an x squared. Don't change that to an x to the 4th. And then 11 minus 12 is going to be negative 1. And that is it for this PlayPosit.